Hey guys, welcome back to Rocket Gyan guys. Today I am Today I am really very excited to witness one of the rarest launches we see of all times. That is the Mars missions, right? Those are the rarest launches we see, and today we have the opportunity to witness it from our eyes, and that too live. So here we have, guys. So as we all know, first of all we get to see what is the payload, what is the rocket and all. So as you can see right now, guys, uh, we have the UAE space agency launching the Mars mission today, and that is the Hope Mars mission. So first of all, the thing which comes into mind, UAE has a space agency. Yeah, it has a space agency which is very young. It was established in 2006. And uh, this is the first interplanetary mission they are doing, but being such a young agency, but having such a big ambition, hats off to them, seriously. So today we have done, after so many postponement because of the weather, today will be witnessing. So uh, what it is all about. So first of all, guys, this is the weight will be around 1.3 tons. This is how the satellite will look like. This will have a 1.85 meter antenna to communicate. 600-watt solar panels will be there to charge the batteries, and the dimensions is this. Okay, no problem. So we have uh, the launch window as the probe name as the Hope probe. So this video isn't very nice to see, like it isn't good, but then also, yeah, that's the video. As you can see, it did not make any sense, so it's okay. But okay, stop. Yeah, I'll explain you everything, no worries. So why Mars? Why are we exploring Mars? So we all know the Elon Musk's dream is to colonize Mars. He wants to be an interplanetary species, wants to make human being a interplanetary species. But what about the other agencies? Basically, they are interested more in science, and of course, one day colonizing the Mars. And it is such an undiscovered planet, and also it has the you can say, in our solar system, the most favorable conditions to live will be on the Mars. So yeah, that's why, and it is the closest one. Those are some little things, and these are some facts about the Mars is the second let it be. So we should just head up at the mission itself. So uh, what is it? What is Emirates Mars mission? Basically, if in short, I first of all, this probe, the Hope Mars mission probe, is not solely developed by UAE. Okay, it is not solely developed by UAE. It is a global effort, but not from the NASA or the other space agency, but from the universities. If there is it is mentioned here or not. um I don't know. I don't think so that is mentioned here. But yeah, it is a collaboration with the university. Basically, the instruments is provided by other universities of USA. Arizona University, Colorado University, if I am not wrong, was two of them. And then the what are the objectives? Understand the climate dynamics and global weather map through characterizing the lower atmosphere of Mars. Basically, they want to map the atmosphere of the Mars. Secondly, explain the weather, how it changes, how the weather change. Explain how the weather changes the escape of hydrogen and oxygen through correlating the lower atmosphere condition with the upper atmosphere. And then the understand the structure and variability of hydrogen and oxygen in the upper atmosphere, as well as identify why Mars is losing them into space. So basically, they'll be conducting, guys, the all the necessary you can say the testing and other things, which is basically they'll be mapping the whole Martian atmosphere to a much larger extent, which has never been done before. The other missions which have okay, so the other missions which have been there in Mars, the atmosphere mapping was to happen at one point only. Okay, like at 3 p.m. Every day the instruments will be switched on and then the readings will be taken, but not in this case. The instruments will be switched on forever. Okay, once it gets there and the instruments are switched on, then it will be switched on forever. And that's why taking one unique orbit to do that, and to map basically every Mars atmosphere. So here we have the three instruments. Emirates Exploration Imager. Basically, this is the camera, high resolution camera. Um, Multi-wavelength imager capable of capturing 12 megapixels of camera images of Mars. Emirates Mars Mission infrared spectrometer. Basically, it is used to measure the spectrometer. It is a spectrometer, right? So it will analyze the wavelengths in the infrared spectrum of for the lower and the upper atmosphere. And then there we have the ultraviolet spectrometer. This will analyze in the ultraviolet spectrum. So this is that. And we have this thing. So here we have a more detailed, and you can say things. First of all, here we go. Mars Mission Infrared Spectrometer studies the lower atmosphere of the red planet in the infrared band and measures the global distribution of dust, ice clouds, water vapors, and temperature profiles. Provides the linkage from the lower to the upper atmosphere in the conjunction with the emas and okay, okay, no problem. Basically, yeah, that's what it will study the Mars atmosphere in infrared. It will study in this is the imager, capture high resolution images, measures the column, not only imager, measures the column abundance of the ozone, measures the optical depth of water ice, capture high resolution images of Mars, studies the lower atmosphere of red planet, provides visible images of Mars during atmosphere. Okay, cool. And then we have the ultraviolet spectrometer, which detects the ultraviolet wavelength, determines the abundance and the variability of carbon monoxide, calculates the three-dimensional structure, blah blah blah. Okay, let's not get into the sciencey stuff. Okay, let's just go and see what else we have in here. Okay, so that's all for the mission profile. Now let's have a look at the rocket itself. So here we have the rocket, guys, as you can see. So today will be they will be launching this Hope Mars probe in this configuration H-2A-202. Basically 202 means uh, two solid rocket boosters will be there. Okay, and this is an H-2A launch vehicle which we will be witnessing today, and it will be launched by Mitsubishi Heavy Industry, basically JAXA, Japanese space agency. That's the thing. So what is the specifications about for this rocket? The type is okay. The main thing which we have to see, the first stage engine, which is an llE-7A into 1, and the second is llE-5B into 1, and this has two solid rocket booster. And yeah, the launch capacity to the geostationary transfer orbit is 4 metric tons. But since we are not just transferring it to the stationary transfer orbit, we are transferring it to the Mars uh, transfer. Yeah, Mars injection. Yeah, Mars transfer. Yeah, Mars transfer. What you said? I just forgot about that technical term here. About it will basically put into a direct encounter with the Mars. Okay, it won't be inside the Earth's gravitational sphere of influence. It will basically give Hope probe the 11 kilometer per second escape velocity. That's the thing. That's why the Hope probe is 1350 in mass. And then the each stage, we have the first stage as liquid hydrogen and liquid oxygen. So it is a liquid hydrogen liquid oxygen kind of rocket as a fuel. Liquid hydrogen liquid oxygen. The second stage also is that only. The thrust it produces is the 1.1 kilonewton, and the majority is produced by this 2.5 each, 2.5 kilonewton each by solid rocket booster. And yeah, here comes the interesting part, guys. um, as you can see here, we have the configuration of the launch vehicle. So here we have the payload fairing. Here we will be having the satellite, and the here we will having the payload adapter. So what is a payload adapter? Payload adapter is where the satellite sits on, okay. And then fourth, this structure will is the payload support structure, wherein it is used to give a more durability and not durability, more strength for to endure the g forces which the satellite will experience in launching in during the ascent. Then we have these helium tanks. Helium tanks is basically used to pressurize the liquid oxygen and liquid hydrogen tanks, so as to give the engine the necessary fuel which it requires, the rate of fuel which it requires. Yeah, I should be more specific. Then we have the liquid hydrogen tank, liquid hydrogen, the liquid oxygen tank, seventh. And eighth is the avionics panel. Avionics, what is that? What is avionics? Avionics basically is used for have various sensors, flight control and all. Basically, if you can say, the computer unit is what we called an avionics. Then RCS, we have the reaction control system. Ninth is the RCS. You won't be able to see it. And but what is reaction control system? Reaction control system is used. It has thrusters. So basically, it is used to control the roll roll. It is basically used to control the roll only and stabilize the rocket. All then we have this 10th as the helium gas bottle for this one, for the oxygen. And then the bell nozzle for the engine. Basically, it is the engine. Then we have the interstage adapter. 12th is the interstage adapter. 13th is as you can see, again the hydro 13th is the liquid oxygen tank. So one thing you must have noticed here is that here the liquid oxygen tank is above, but here the liquid oxygen tank is below. So that is one thing which should be noticed, that does not happen in the rockets. We have the configuration as the liquid oxygen below and the other fuel, no sorry, the oxygen above and the fuel below, but it does not happen in the second stage of this. So it's a good thing to be noticed. Then we have the 14th as the center body section, and then the hydrogen tank. Then here we have the 16th. These are the solid rocket boosters, the first stage engine. 17th is the first stage engine. 18th, you won't be able to see it now, the auxiliary engine. Here we have the helium bottles. 19th is the helium bottles. You won't be able to see it, but it is used to pressurize that. And then yeah, that's the thing. So that's what we have, guys. That's what you needed to know about the launch vehicle which we are having today. And yeah, that's the thing which you should know before seeing the launch. Now let's me just see if do we have the stream yet or not. Let me just see it. Do we have the stream or not? We have the stream, but right now it is in Arabic. uh, okay, maybe I would be needing to change the translation. I'll be needing a translation. No problem, I'll do that.
Was about the average, age of the team.
Okay,
So you can think
we
that,
have the launch,
what
guys,
that does for
with
the
that stream.
generation today and what that does for the country. I mean, the UAE is pushing for a knowledge-based industry and
Let
how
me just
best to
switch it
do it
over to that.
and really push and invest in the generation. We're so blessed in this country. I mean, the UAE is pushing for a knowledge-based industry and how best to do it
Here we
and
go.
really push and invest in the generation. We're so blessed in this country that we have leadership like Mohammed bin Rashid and His Highness Sheikh Mohammed bin Zayed, who, really acknowledge and understand the investment in people, in education. They see that as no loss at all. And that was, the message that was given by His Excellency Ahmed Al where, they
Hi
had an
Christina, hi
inspirational
Luis
meeting,
Carter,
with
and
both His
hi Rich
Highnesses.
Hassan.
The message that was relayed was phenomenal, basically saying that the mission is done, it's been accomplished. You know, it's not about sending the probe to Mars. It's really about the 5.5 million hours of UAE engineers, put time, dedication, sweat and blood into this project.
Absolutely.
That is the true success of this project right now.
Loads more to talk to you about on the programme this evening. Probe to Mars is extremely complicated, but the data that we hope to gain once we get there has the potential to be extraordinary. The first complete picture of Mars's seasonal atmospheric cycles.
Earlier today, I stepped into virtual at the Hope probe and its mission. So let's take a look. The UAE is on a mission to explore Mars. And through the Hope probe, it will become one of the handful of countries that have done so. Let's take a look at the details of this historical mission.
Whoa.
The Hope probe will launch from the Mitsubishi station on the Japanese island of Tenaghashima on board the Mitsubishi H-2A carrier rocket, just under 35,000 kilometers per hour. The journey from Earth to Mars will take approximately 7 months and coincide with the 50th anniversary of the founding of the United Arab Emirates. Now, in order for the probe to reach Mars before this historic date, it must launch within a short and specific time frame known as the launch window, which runs from the 15th of July to the 3rd of August. Now, the reason for that is because the Earth orbits the Sun faster than Mars. Sometimes it's ahead of it, and sometimes the two planets reach their closest point every 2 years. And that phenomenon is happening right now. Now, during its journey to Mars,
that is not the thing, guys.
will travel 493 million kilometers at a speed of 121,000 kilometers. After the probe detaches from the missile, it opens its solar panels and turns toward the Sun to charge its batteries and other solar-powered equipment. The probe will need to change its position from time to time. Firstly, to recharge and also reorient its satellite towards the Earth to maintain contact with the operations team. The Hope probe uses a star tracker to find its location and direction. Upon reaching Mars orbit, the speed of the probe will gradually slow down to 14,000 kilometers per hour. It will then enter a broad elliptical orbit around Mars before moving to a scientific orbit closer to the red planet. At that point, it will turn on its sensors and start collecting data estimated at 1,000 gigabytes that will be transmitted back to Earth. The probe sends the information to the Mohammed bin Rashid Space Centre every 13 to 26 minutes. The probe mission will last for 1 Mars, which is equivalent to 687 Earth days. And after it settles in Mars orbit, the Hope probe will need just 55 hours to complete a full cycle around the red planet. At this point, the Hope probe's scientific begins to present the first comprehensive study of climate change on Mars and its different atmospheres. It will help to discover why the upper layer of Mars's atmosphere is vanishing, and it will do that by tracking the behavior and the path, the exit of both hydrogen and oxygen atoms. The Hope probe will also investigate the relationship between lower and upper atmosphere on Mars and provide the first and most detailed images of changes to the Martian atmosphere throughout the days and seasons of the Martian year. But that's not all. The Hope probe will also on the surface of Mars, such as dust storms and temperature changes. Now, why is the exploration of Mars and its climate important to humanity? In Mars, we can find the most important secrets to the climate changes we are experiencing here on Earth, and understanding what happened to the red planet, it will help us to avoid the same things happening to it. Now, here is one of the biggest questions facing the human race right now. Could humans live on Mars one day? None of the Mars probes or vehicles have definitely answered this important question yet, but the comparison between Earth and Mars may give a clear picture. Now, in its geographical appearance, Mars is somewhat similar to its neighbor Earth, as it is also a rocky planet. The surface gravity is about 38% compared to Earth. And while from space the Earth appears to be blue and green, Mars, as we can see, is reddish-orange color. And this is caused by the presence of iron oxide atoms or rust in its soil. The dry canyons and valleys with steep slopes in its surface indicate a possible sign that water flowed at some point. Mars's air consists of 95% carbon dioxide, 3% nitrogen, and a small portion of oxygen and water. The surface temperature of Mars is 27 Celsius at its highest and 133 degrees Celsius at its lowest. The HOPE probe and the data it sends will increase our understanding not only of the chances of life on Mars, but also of the ones here on Earth. Knowledge is a powerful thing. I tell you, Ray, winter is my favorite season of the year, and that temperature just draws me, no matter how weak the gravity is.
You actually look like you had a lot of fun doing that.
Yes, Martian.
Absolutely, yes.
So cool,
okay, it's a pleasure now to welcome onto the show David Brain, who is the Mars planetary scientist at the laboratory.
Guys, if you haven't subscribed till now, just subscribe, because I'll be covering each and every launch. The NASA's mission, also the China's mission to the Mars, and I cover every launch that happens. So just subscribe and hit the like button right now if you find it also cool.
Can you tell us about the collaboration that the University of Colorado bobbed with the UAE Space Agency and Mohammed bin Rashid Space Centre on this probe?
Yeah, the University of Colorado, along with a couple of other institutions here in the U.S., the University of California, Berkeley, Arizona State, and Northern Arizona University are knowledge partners on the mission. So we've formed a merged team between people from the Emirates, where both on the engineering and science teams, we have scientists and engineers from both countries working side by side to set the objectives of the mission to build the spacecraft.
I see. Mr. David, of course, thanks for being...
So guys, I will just want to say something. There is two things which I found wrong in that. First of all, he mentioned that the Mars is the closest to the Earth when it is happening today. That's why we are launching it. That's not the case. It is not closest, but it is launching. We are launching today because we have the home and transfer window, and that is the most fuel efficient window we have. Okay guys, if I can have the J for the thing which basically explains that orbit of that, so then I'll be able to tell you more clearly why am I saying that. Basically, in layman words, the apoapsis, the highest point of the orbit, should intersect with the Mars orbit, and at that point only the Mars should be there. So it is not like when the Mars and the Earth are closest to each other. No, it is not like that. We have around 44 degrees angle for the Mars, between the Mars and the Earth. If we take the vertex at the Sun, around 44-degree angle, and that's when we launch the mission, and that is happening today. And the other thing, yeah, as the one Vigo mentioned, that why did they call it rocket a missile? We call it a missile because I don't know why did they call it a missile. Missile is also one kind of a rocket, but only that we don't have a payload, but we have the ballistic material and the explosive material inside the fairing. You can say not the fairing is there, but at the top of the rocket. So that's the only difference. And basically the missiles are we have SRBs in that, but that does not happen in the case of the rocket. So yeah guys, just hit the like button right now if you want to see more of these things, and subscribe, because I need to get my subscriber goal cleared today. We have 54 viewers, 54 subscribers. I need it right now. Just hit the subscribe button and hit the like button too, and support me guys.
Pad in Tenaghashima Island in Japan is not just a probe mounted on a rocket. It is an accomplishment that supposedly required 10 years, but together That is like living 48 hours in 24 hours. How do you manage that?
Well, I can't take credit for it as a scientist, so I think that means I'm permitted to brag a little bit. The definition of the science part of the mission was just 100 days in the beginning, so that was very accelerated. And everything else that's been happening with the schedule since then is all thanks to the engineers who had to work across 2 different continents in different time zones and fly back and forth, and also get a probe through the launch pad in the middle of a global pandemic, which is nothing short of amazing as far as I'm concerned.
No, absolutely. It's been an extraordinary achievement. So let's talk about the mission itself, the Emirates Mars Mission. What do you think it will do to complement our knowledge, what we already understand about the Red Planet?
Yeah, the addition here, scientific, in my opinion, is a global picture. We've had rovers and landers on the surface of Mars that tell us about the atmosphere at one location 24 hours a day, or 24 and a half hours a day, as is the case on Mars. And we've had orbiters at Mars that orbit, but they always orbit at a single time of day, maybe 2 a.m., 2 p.m., and tell us about the atmosphere there. And if you think about Earth, if you just understood the atmosphere at one time of day or one location on the planet, it would be really hard to understand how the atmosphere works as an entire system, as a whole climate affects every place on the planet. And this is what the Hope probe will do for Mars science. It will give us every location on Mars at every time of day, every 9 to 10 days. And that will allow us to understand how the atmosphere works together.
Do you feel in that sense, therefore, that the eyes of the scientific community are really on the UAE at the moment, and on this mission in particular? Is it an exciting mission for people around the world who specialize in this area?
Yes, absolutely. For the Mars atmospheric science community is very exciting. The Mars community in general is exciting as well. And I'd say early on in this process, 6 years ago, there was some skepticism in the Mars community that a country who had never sent a spacecraft to another planet was going to be able to contribute meaningfully to the scientific discussion. And now I think people are excited about the data that will be returned.
I see. Of course, Mrs. David, one last question quickly. Great changes happened to humanity when they discovered fire, power, electricity, and oil. What happens when human beings venture into space, to Mars? What drives us to discover other planets, strategically, economically as well?
There are several reasons to venture forth, and I think it's part of the human spirit to explore and to venture forth. Maybe a more pragmatic answer is that currently all of our eggs are in one basket. Our whole species is here on Earth. And of course, we should work to solve the problems here. In the event that we can't control every problem, I think it would be essential to the survival of our species to have humans populate and live on other planets.
See. Mr. David, the Mars planetary scientist, Laboratory for Atmospheric and Space Physics from the University of Colorado Boulder, thank you very much. That is a lot of information to juice up.
Yeah, and I love that phrase, to venture forth. It kind of encapsulates the excitement of the...
So guys, yeah, that is a thing which they are discussing right now. It is a cool thing, right? And one thing which I wanted to tell you, that yeah, as Jeffeth mentioned, that the missile is the guided one and the rocket is not, I can't say it is a non-guided one, yeah, but okay, you can say that. Okay. What is the time now? Do you got okay, let's just hear their commentary only, then I'll tell you.
So just under an hour, I think.
Under an hour for the 10 most important seconds in 2020. Can you tell us, how do you feel? How do you think people feel? How does Japan feel right now?
I mean, the way I feel right now is, just sheer excitement. I'm watching His Excellency Bilhol, the team over there at Tenaghashima, I guess you'd say they're over the moon, But I think this is all, the 6 years that the team have been working towards this has just been phenomenal, As you heard,
Yeah, guys, this thing which you are facing, it is from the back only. No. Wait a sec.
You know, but I think this is all, you know, the 6 years that the team have been working towards this has just been phenomenal. You know, as you heard, you know, the UAE go out and decide to buy a sat. Really wanted to make sure
this latency and this thing which you are hearing right now, it is it is not my problem. This thing is not in my end. This is from the back end only.
Point right now where, you know, information is going to be coming out, and as mentioned, you know, this information is not just arbitrary. This is really information being looked and sought out for in the space community today. I think, you know, the teams that were over in Japan, they've been there, as I mentioned, since April. I'm sure they miss their families, but, you know, these guys are heroes to us. You know, they're group of 17, been there since April, haven't seen their families, haven't seen their kids, and they've just dedicated their whole time now to making sure the success is there. You know, with the delays that have happened with weather, that's part of the natural launch campaign. All of these things, you know, the engineers look through this, they anticipate these things. We have a window, calculations are pre-calculated on a daily basis, anticipating, you know, a disturbance due to the weather or a delay due to that. So, I mean, from my side, being here at the studio, you know, it's a little different. You know, you don't have the air of the whole team around you, but I know at the UAE Space Agency, we have a team over there. They have a gathering put together, and I'm sure, you know, they're all celebrating right now as well. And yeah, you know, and the whole team's over at the MBRSC are doing the same.
I mean, just you mentioned the delay. I mean, you know, for us, we were sort of ready to gearing up to go on air. We're very excited about it and gearing up again. And we, you know, we totally understand the situation means that you have to have that delay. I'm thinking the team over there, slightly more cooler, you know, a bit more ready, and actually maybe potentially expecting the delay to have taken place.
Yes, honestly, it was quite funny. It was probably around the 18th. It was actually just the weekend before that I was asked to join the EMM media committee. So, you know, I was mostly working with the project director, Al-Amal, you know, every other day or so. I communicate with him, make sure things are going fine, you know, and reporting up. And so, you know, we were pretty much done and ready, and I was asked then to join the media team. And yeah, I could sense the excitement, you know, and the positivity and the whole push on that aspect. I was watching the weather all the time and thinking, guys, we need to make sure we're planning as well, that, you know, there could be a delay coming up here, you know. And so, like you said, the engineers, it was expected, you know. Of weather reasons, but luckily, you know, we MHI, you know, they're the ones who are responsible for this launch. So they're the ones who are overseeing this launch, and they're the ones responsible to get, you know, a successful the right track and right line into Mars. So they're taking that risk, and so for them, it's a huge responsibility, and we need to respect those decisions. You know, we can't know where. We said it was going to be the 15th, so it's going to be the 15th. No, there's way too many variables when it comes to launching anything into space. I mean, you know, the Earth is like a magnet. If gravity was probably 5–10% stronger than it is, we still wouldn't have the technology to leave Earth today. Wow. I mean, you know, if you actually look at the launch vehicles out there today, around 85 to 91% is fuel. Think about
weight,
that.
That's the weight.
That is the weight of the fuel. So you're looking at 91% of the launch vehicle is fuel. And that means 9% is metal, structure, tanks, engines, people maybe, everything else. So imagine a little bit stronger. We still wouldn't have the technology to get out and get into low Earth orbit or even have satellites around us today.
Absolutely.
You know, Fed, 10 years ago, if someone would have come and told me, you know, in 10 years, we're going to be going to Mars, I I'd actually stop the guy and tell him, what are you talking about? But, I mean, now with the information that you're telling me, I mean, think of this. Mars's gravitational pull, if you compare it to Earth, it is 38% weaker.
Yeah, it's about a third.
Which means if for one of the projects that are one of the missions that are there actually on the ground of Mars is a rover called Curiosity. Do you think that the rover's rotation requires the mathematics of its own in terms of acceleration? Otherwise, it could flung itself on the planet? Rhetorically.
Oh, no. You know, I wouldn't go that far. You know, you do, it's a third of the gravity of Earth, but you see, they actually use, you know, landing because when you... The problem is you can't use parachutes, really. You know, they're not really that effective because the atmosphere is also just a sixth, I believe, of what we have here on Earth. So parachutes aren't really effective. So they do use boosters, and, you know, you've seen, I'm sure, things before where they have like bubbles wrapped around in this thing, and it sort of bounces around and comes to... So, you know, that works because it kind of floats almost, you know, into the planet. So it is very different, you know. I read somewhere once that a mission to Mars would probably... I think they said just to get 400 kilometers away from Earth probably uses up 80% of the fuel.
Yeah.
So just to get 400 kilometers off the surface of the planet Earth.
Wow.
You know, so less is needed because of the gravity. And, you know, then the rest is basically gravity will basically pull you back as well once you get the track and you get moving back here.
Absolutely fascinating. Fahad, stay with us. Please don't go anywhere,
Yes.
I promise. We're going to head over to Faraz Javid. He's over at the Mohammed bin Rashid Space Centre. Let's find out what's going on over there. Faraz, can you hear me?
Ray and Yusuf, the excitement is building up over here, and I gotta say it's electric, and why not? Because interplanetary mission, which is all set to take off from the Tenaghashima Space Centre just about an hour's from now. I would say 1 a.m. UAE time to be exact. Now, just a couple of things that I would like to remind the viewers is once the rocket takes off is the same place where UAE's first Emirati-built KhalifaSat was launched back in 2018. So it's definitely the second home for some of the engineers out there who are stationed over there for the probe. And of course, when the launch happens, it'll take the launch vehicle approximately 11 minutes and 24 seconds to reach outer atmosphere. Now, this is a very crucial stage for the probe, and I'll tell you why. For two reasons. As soon as the launch vehicle, it's gonna deploy its solar panels, which will power the batteries that will help the probe make the 500 million kilometers journey. Second is establishing the connection over here with the ground team. That is super crucial because this is exactly what is going to allow the ground team over here in Dubai to control the probe. Now, the first connection will be established with a ground station in Madrid. Then they will pass that connection over here at the Mohammed bin Rashid Space Center in Dubai. This is where the mission actually begins. Now, for 24 hours, 7 days a week, for the next 30 days, the team over here, and obviously checking the trajectory, fixing the telemetry that's coming in. Based on that, they will be making all the trajectory corrections and everything. And then after the 30 days is passed, the team over here will be connecting with the probe for about twice a week, and each connection will last about 6 hours. Now, throughout these connections, it's super important because the team over here will be making sure that the probe is headed towards its right path towards the Martian planet. And of course, let's not forget, cruising at a speed of about 121,000 kilometers per hour. Now, another important factor to be considered in this is the telemetry data. Now, there's going to be a lag based on where the probe is. The lag could be anywhere between 15 minutes to 45 minutes. And based on that, which basically means that by the time the probe actually sends over here, it could take that long and vice versa. So they have built the probe with a fail-safe device. So if it does not receive the right instructions on time, it will hover around at a fail-safe position. And of course, I've got lots more facts to share with you guys throughout the evening, or the early morning rather, throughout this live broadcast. But for now, I'm gonna send it back to you guys, Ray and Yusuf, at the studio.
Thank you so much, Faraz. One thing I just wanted to bring up before we go any further is we're talking about a lot of historical firsts this evening. The first Arab interplanetary mission, our first mission to Mars, of course, but we're going to hear the very first countdown to launch in Arabic, and that in itself is going to be an amazing moment.
No, that's for sure. I mean, you see the, Misbar Al-Amal, this was not just something for the UAE, His Highness, the leadership, they saw this as something bigger than just the UAE itself. And this was dedicated to the Arab world. And I think that's what made this, so much bigger and so much more exciting. Bringing the culture into it, bringing the Arabic side into the countdown. They've done so many different social media events and aspects, which have just been phenomenal in that aspect. Just foreigners now, who have done these videos and counting down. And it just sends that message, it's not just to the youth of the UAE, it's to the Emiratis, it's to its residents, it's to the GCC, to the region, and to the whole Arab world.
It sends a message.
It's a huge message. I mean, and just, hope. Why did they call it hope? This was really a part of the whole thing. It's, part of the strategy we have at the UAE Space Agency, and part of the strategy that's actually been put in place for the space sector is really to have a project, because that's what brings humanity together. I've heard lots of different astronauts who have come back, and they say that as they start to go further and further, they start to point at, oh, that's my country and that's my country, and then it's, oh, that's my continent, that's my continent, and then it goes silent, because people realize then, hey, we have one Earth,
Yeah.
There are no borders, there are no lines. And that's what, honestly, I found is really fantastic when coming into this space. I mean, the previous industry that I was in was very secretive in the sense, and, it was all very much, aligned to country capabilities and all. And coming to the space side, it's been phenomenal, because we pull together academia, we pull together students, professors, industry, scientists from all around the world, and that's just what's made all of this so phenomenal for me just in the last 5 months of being part of all of this,
Absolutely.
Absolutely. There's a lot of messages that this mission sends its completion instead of 6, amongst other things that we'd like to get back to. But right now, we have a very interesting guest with us, ladies and gentlemen, and that guest, of course, is Emirati astronaut Sultan Al-Niyadi. And the right man for the right occasion, joining us right now in a video call. A very good day and a good evening to you, Sultan, wherever you are right now. And thank you for joining us. And let's break it with the first question. Last year in Kazakhstan, it was a huge moment when Hazal Mansouri, your colleague, your brother, became the UAE's first astronaut and went to the International Space Station. Now, and we kind of know that at those last 10 seconds at launch, you were concerned for him. How are you feeling now towards a mission that is unmanned, but it carries the hopes and dreams of 7 Emirates and the entire Arab nation?
Well, first of all, good morning, and thank you for having me. So I think in terms of personal feelings, I think it's different. Last time it was a manned mission, so it was a human being on top of the rocket. Now we're talking about a satellite. In terms of the excitement, I think it's kind of similar. It's something new for the whole nation, for the whole region, and we are excited for it. And it will be quite an interesting journey, because it will last for 7 months. So I think it's going to be a really exciting 7 months ahead.
Yeah, it's actually going to be a journey for us, as well as the probe that gets sent back home to Earth. How important do you see this mission being for the UAE space program, but also for the Arab world as a whole?
Well, it's called Hope Probe. The name was an indication at the time when the Arab world was facing hardships and difficulties. So it's a strong message. Obviously, it's a big milestone for the UAE, and it's a matter of capabilities, developing the technology, and enabling engineers, scientists, and building a platform for this nation and the Arab region.
So part of reaching this historic moment has been the UAE's young people. How, how can that add up to the UAE's youth, and how can they enrich this program and this mission in the future?
As you may know, that the average age of the engineers in the MBRC are 27, or is 27, and to have these projects inspiring them and build some sort of enthusiasm to look beyond normal. So I think in the future we'll have more exciting projects. Yes, we have the capability to build satellites, and through a good partnership we did send an astronaut, and hopefully this will be sustainable. And now we're sending probes. So in the future we will definitely look into something more exciting, like sending landers to Mars again, or maybe go back to the moon with the help of the international community, and especially in the space sector. So I think it's very exciting ahead of us.
Well, we seem to have a little bit of interference on the line, but we want to keep talking to you, Sultan, because it's so fascinating. You're one of the only people who's actually been through the UAE space program, through training for it. What is it about space exploration that excites you so much?
Well, I don't want to sound cliche by saying it's like a dream since childhood. It is. But in terms of the current science that we should be involved in, it's very exciting to help humanity explore space. It's very exciting to be among the elite club of space. They're less than 600. So to be doing these some sort of exciting job of floating both international exploring space through missions to Mars, I think that is a very exciting thing to do.
So, Sultan llA, the Emirati astronaut, thank you very much for joining us at this moment, at this historical day.
Yeah, we would love to have chatted to you for a little bit longer. We're just fighting against a bad line there, so sorry about that. Now, anyone who's been following the Emirates Mars mission will know that the launch had to be delayed twice due to unsuitable weather conditions in Japan. Now, fortunately, we had more than one opportunity to get the Hope probe into space. Here's more information about that launch window. In order to reach Mars, the Hope probe must leave the Earth during the launch window, which this year started on July 15th and finishes on August 3rd. After its launch, the Hope probe will travel in an elliptical orbit around the Sun at a constant measured speed. Its path will ultimately meet the orbit of Mars on a journey that lasts from 7 to 9 months. In the event that the weather is bad or there's a breakdown during the launch window period, the launch must be postponed until the next window, which occurs in 2022.
Welcome back, and that was a lot of information, and yet there is more. There is more to this than meets the eye. We're back with Fahad Al-Mhari. Fahad, we've heard a lot of information, and what catches the eye, I have to say, is the fact that this project was estimated and it required 10 years to be finished, but it finished at 6. Yet, it is really insured. And we're not talking any regular insurance policy here. We're talking about a fault-safe insurance policy in case a communication happened. We know that there is a communication delay between 13 and 26 minutes when it comes to communication. So, and quantity were both maintained in this project in merely 6 years. How do you...
Well, you know, again, I've only been part of this project since about February 14th when I joined the agency, and you know, I'd heard a lot about the project. You know, every time I pass the Mohammed bin Rashid Space Centre, you know, you see it there. My kids had always asked about it, and you know, once I joined the UAE Space Agency and you know, realized like, okay, well, we're going to be part of this project now. So it's you know, it's exciting. I mean, the teams have been coming back and forth from the U.S. You know, the achievement of actually getting that done within the 6 years is phenomenal. I mean, it's just look at where we are as the UAE, you know, as the space sector. We only started this, you know, llA, I guess, I mean, really started, I would say, with, you know, our great father, Sheikh, it was Sheikh Rashid and Sheikh... sorry, Sheikh Zayed Nahyan.
Yes.
He was the one who really had that dream, and you know, he called in, and the team from the Apollo mission 17 actually came to the UAE. I believe it was in 1976. Yes. So even at that time, you know, there was always the questions: why Mars, go to space? What's the big deal about that? And you know, from that time, the seed was planted, and you know, we started off with a company called llA. That was the first, you know, satellite communications company that came up. And then you had JAXA that came through after that. Then you had the establishment of the Emirates Advanced Institute for Science Technology came up. And that was then taken in when Mohammed bin Rashid Space Centre was set up in 2006, I believe.
Yes.
You know, the UAE Space Agency started in 2014, so 3 days ago we celebrated our 6th anniversary.
Wow.
And you know, to think that, okay, 6 years after that, where there wasn't really this international collaboration like we have today, you know, it was companies doing their own thing in isolation, space policy, there was no space strategy, there was no space law. And you know, that Hazza al-Mansouri and you know, that they went to the International Space Station last year, you know. Yeah. All of this has been put together as part of the space sector, the 2030 National Space Strategy. So all of the things that you're seeing today is part of that strategy, you know, and the space law that has come up as well. So all of the document, and it's a document that the team have spent years on, you know, starting off with the policy, the strategy, and now we have the UAE space law that was actually just launched in December last year. You know, to have that already, and the space law is so forward-thinking, the strategy is so forward-thinking. We have other countries now coming back to us, and I would even go as that the U.S. is even now looking at updating their space laws and policies, and they're coming back to us, asking us, what is it that you guys did? What have you added? And how can we work together? So it's not us anymore, you know, taking what's out there, but we have adopted it, and we've thought about the future developments, and this is where we stand now. You know, we're recognized internationally. And
one of the things that I'm most fascinated by and impressed by in many ways is the fact that all of this data, all of this research from the probe when it's orbiting Mars will be sent back, and it's going to be, obviously it needs to be validated first, but then it's going to be shared online. It's going to be available to the entire world, whoever's interested, from scientists to, you know, the general public. Complete sort of open policy, open door policy to the world. It's saying get involved in our research, and you know, that's very sort of original and quite forward-thinking, I think.
And I think that's the thing, you know, I think, you know, I'm sure you've heard before from Her Excellency Sarah Al-Amiri, you know, there's plus institutes that have signed up to receive this data. You know, the great thing is we also have students here in the UAE who are actually also waiting for this data.
Yeah.
We've got some fantastic groups that have been set up. You know, one is the GSI, the Global Space Innovation Group, and that's been phenomenal for us because we have students and professors who are actually working on projects today, projects that the UAE Space Agency are funding or the universities themselves are funding. We have about 33 projects ongoing right now to do with space. You know, from CubeSats, certain services, R&D, you know, specializing in all sorts of different things. And it's been phenomenal, honestly. It used to be a road show, sort of the team would get together once every quarter, but it's been happening on the situation of the COVID and, you know, webinars and all the virtual meetings. It's been fantastic. You know, we've been holding meetings now with 100+ people involved. And they've been presenting their projects, talking about really what's next, what the next R&D things are. And it's really great because all that information is not kept to, you know, that project or that person. It's shared with the whole community. And anyone can come in, anyone's welcome to join that. So it's been great. Another fantastic group that we have is the Global Space Accelerator program that's been put together. And that has also been something great. You know, the last webinar we did, we had over 500 people joining us, over 100 questions asked and answered. You know, I make sure I'm a part of these because I get so inspired by the questions and by the community and by everybody being involved in this, you know. And that really just drives everybody forward, you know, with everything that we have.
We're going to get back to that and we'll have more for you for ahead. It's going to be a long, beautiful night, of course. And we're going to go with Professor Bruce Jakosky. He has been involved in more than half lunar and solar missions over the decades, starting with the Viking Mars landers of the 1970s, and is the principal investigator for the Maven orbiter, which is currently gathering data from the Red Planet. He joins us live from Colorado. Being with us.
Hi, my pleasure to be here.
Thank you very much. Now, Professor, the UAE and the University of Colorado worked together to make the Emirates Mars mission happen. How are you feeling with the launch less than...
My heart is in my stomach. This is the single biggest opportunity to have a problem.
Talk us specifically, if you don't mind, Professor, through the actual scientific implements that you helped to design, helped to construct. I'm thinking specifically of the EMAS, because once the Hope probe is orbiting Mars, they're going to be doing all the work. Tell us about them.
The goal of the mission is to understand the atmosphere and how the lower atmosphere connects to the upper atmosphere. So with the llA instrument, we'll be at dust and clouds in the lower atmosphere. The mirrors will be looking at temperature and water and clouds in the lower atmosphere, and EMUs will be looking at the upper atmosphere. By looking at them both at the same time, we can see how they couple together.
Professor, there are a number of active probes currently orbiting Mars. What could the Hope probe's mission tell us that we don't already know?
It was designed in order to answer questions that have been raised by previous missions. So it's the next set of measurements, the next set of observations. Our goal is to understand how the atmosphere works today and how the atmosphere has evolved through time. By looking at what's going on today, we can see what has happened in the past and infer how much gas has been lost to space and how the climate varies and has varied.
In terms of that research, how can it actually help us here on Earth? What are the benefits of this research that we can put into practice here? What can we learn from it?
That's a very difficult question. If we wanted to learn more about the Earth's atmosphere, we studied the Earth's atmosphere. Looking at Mars, we understand how atmospheres in general work, and that helps us understand the potential for life on Mars and the potential for planets around other solar systems.
Professor, it is said that the red planet and our blue planet are quite very similar. Now, if they would really have exclamation marks on top of them. But can you tell us in what points are they similar or alike?
Well, they're similar in that we see a lot of things going on in Mars that have happened or are happening on the Earth. We see clouds in the atmosphere, dust storms in the atmosphere, weather. And on the ground, we see volcanoes, polar caps, river channels, things that look very familiar to us. So there's clearly been a lot of commonality between the two planets, yet they're very different. The Mars atmosphere is about 0.5% as thick as the Earth's atmosphere. It's far distant, so it's colder, and Mars doesn't have oceans to buffer the temperature and atmosphere. So while they're very similar, they're also very different.
The current missions on Mars to Mars, such as Curiosity rover, are geological, but this is actually an ecological mission. What are the differences between them, and would you say that one is actually more important than the other?
Well, of course, studying the atmosphere is the most important part. Really, though, we need to study all the different components of the Mars environmental system in order to understand it. The atmosphere connects to the upper atmosphere, it connects to the polar caps and the surface. By studying each piece of the surface with a rover and using remote sensing to study the global behavior of the surface atmosphere, we can see how they couple together.
Professor, so by the next year or by the next couple of years, humanity will be informed more than ever about the geology, geography, and ecology of the red planet. How long do you think it could take before there is a colony on Mars? Do you think humans can be the first Martians?
We can do that. The current plan would have, depending on who you listen to, have humans on Mars either in this decade or the next decade. And once we have humans there, it's not a big step to have permanent participation, permanent habitation. So I think it may not happen in my lifetime, but certainly in the lifetime of the people watching this.
Yusuf was explaining in your introduction how the focus of the missions, or rather how you've been involved in missions since the 1970s. Have you seen a change in the focus of the missions and the sort of the targeting of the information that they're trying to discover?
When we first started sending spacecraft to Mars, really in the 1960s and 70s, it was the first look at the red planet. We didn't know what to expect, we didn't know what to see, and everything we saw was brand new. As we learned a little bit more, we were able to ask very specific questions about how the surface has evolved, how the atmosphere has evolved, and between them. And each mission we send now is designed to address a different set of questions. One of the things that I've noticed over the decades is we're making new measurements, we're making them in a new way, and it's as if we're seeing the planet for the first time. Every mission has made fundamental discoveries that tell us something against us. I have every expectation that the HOPE mission will not only answer our questions, but also throw some things at us that are brand new and totally unexpected.
Here's another category of questions we wonder if the probe is going to answer, and perhaps this is the most favorite category of questions. Extraterrestrial life, Professor. I think it is one of your passions. Now, could this search, such a search, could it be carried out by the HOPE probe to help?
HOPE is not designed to search for life. It's designed to understand the history of the climate. But the climate, the weather, the environment is fundamental to whether life can exist on the planet. So all of these missions, by studying how the different of the environmental system play together, are really getting at the question of habitability by microbes and whether there could be life there and whether there is life there. I think that the questions about life are most likely to be answered when we can go to collect samples, bring them back to Earth and study in laboratories here. And that is part of NASA's and ESA's plans right now.
Professor Bruce Jakosky, thank you so much for joining us from the United States. I was going to ask you if you're still excited about the search for Mars after 50 years of research, but I can tell the answer is definitely yes. We appreciate your time.
I'm very excited. Keep your fingers crossed for a successful launch today.
Absolutely. That's the key message. Thank you so much, Professor.
Thank you very much.
OK, now, launched at the start of this month by the UAE government, registration for the Arab Space Pioneers programme has now closed after drawing an incredible 37,000 applications in just 2 weeks. Katie Jensen has more.
As the UAE prepares to make history tonight, so it will in the coming months, thanks to the launch of the Arab Space Pioneers programme, a first-of-its-kind specialised space training programme for the region. Launched by His Highness Sheikh Mohammed bin Rashid Al Maktoum, UAE Vice President, Prime Minister and ruler of Dubai at the start of this month, in collaboration with the UAE Space Agency, 37,000 applications within just 2 weeks. Registration has now closed. The selected finalists will receive the chance to undergo specialised training in line with the Emirates Mars Mission that combines theory as well as hands-on practical experience. Those chosen will also receive a 3-year residency visa in the UAE and have an opportunity to build advanced satellites. Officials say that scholarships and other financial incentives will also be on offer. More than 19,000 applications for the program came from Egypt, followed by 6,000 in Iraq and several thousand in places like Algeria and Morocco, as well as the UAE. The next stage of the will see a carefully selected committee of scientists, researchers and thinkers evaluate the applicants based on achievements in science and research. On September 29th last year, the UAE sent its first Emirati astronaut to the international space. Tonight, it will launch the first Arab probe to Mars. And in the coming years, this project is also set to transform the Arab space industry as we know it, helping to educate the next generation of Arab astronauts, researchers, engineers and experts in a variety of space projects for years to come, and showing that once again, the UAE can possible. Katie Jensen, Dubai 1.
A 38% gravity weaker than our planet, and it still pulled the rocket and dear viewers, you're watching our coverage from Dubai 1. My name is Yusuf and this is Ray, and we have, of course, Fahad Al-Mheri. Right now, we're going to move to a network of correspondents as we continue the countdown to launch. Let's check in with Faraz Javed at the Mohammed bin Rashid Space Centre. Faraz.
Yusuf, the atmosphere over here is absolutely electric. As you can see right behind me, everyone is glued to the big screen where you can see the mission control at the Mohammed bin Rashid Space Center. And of course, we've got millions of eyes, whether it's through watching through our television network or through a live broadcast, whether it's the U.S., U.K., Singapore, you name it, people are watching this historical moment. And of course, one of the exciting thing about this probe is the design. Now, more than 150 Emirati researchers and scientists have been part of this since its inception 6 years ago, with a 735 million dirhams budget. Now, just like everything the UAE does, which is unique, the design for this probe is no different. Now, I was speaking to the senior director of the engineering department here at the Mohammed bin Rashid Space Center, Al-Amal, and he was telling me that most of the elements of this probe were actually fabricated here in the UAE. About is the installation of a plate that has the signatures of leadership. And this, of course, will be acting as a beacon of hope for humanity in outer space.
Well, it's quite important to showcase the leadership in this program as we receive the commandment from our leader.
それでは
and His
今
Highness
回搭載する UAE 火星探査機ホープについての詳細をご紹介いたします。
UAE 火星探査機ホープは火星の年間気候の全容を捉えるために火星全体を周回しながら火星大気の観測を行います。高い分解能で低層大気の様子を撮影するための高性能デジタルカメラである EXI。赤外線で低層大気の
So guys, here we are at the launch site here, launch stream here, because there we could have seen the launch, but that would be a, you can say, a smaller view. Okay, so I have now shifted it to the official broadcast of the launch, and yeah, that's the thing. It would be better to see this, right?
大きく3種類の観測機器を搭載しており、得られた情報は
And now it is 12 minutes to the launch, guys.
Hope はアラブ地域への誇りと希望のメッセージを掲げ、宇宙開発を加速し、教育、科学、技術分野を推進させることを目指しています。
続いて H-2A ロケット42号機についてご説明します。今回の H-2A ロケット42号機は UAE 火星探査機ホープを所定の軌道火星線軌道に投入することがミッションとなります。
radiation,
H-2A ロケットによる惑星探査機の打ち上げは4機目で、火星探査機は初めての打ち上げとなります。H-2A ロケットシリーズは2001年8月に初号機を打ち上げ、
the outer space, what kind of elements it'll face, and once it reaches the Martian planet, what kind of climate it will have to face. Here, have a listen.
Well, it's going in space. Space is a hostile area. It's filled with radiation. The temperature there is quite extreme compared to what we have here on Earth. And it's all being done through equipments that are well designed and manufactured to make sure the cruise of the probe is directed towards Mars correctly. So technology is helping us here to go through this harsh environment in terms of weather, in terms of radiation, and especially for radiation, you are dependent on these electronics on board. So any error in these computers will have a negative impact. But so far, with the design and what we have done so far, we're quite sure that it can withstand successfully this kind of environment. Going to Mars itself, it will require some correction, let's call it, where a slight maneuvers in the orbit direction will make us target the right or the correct Martian insertion orbit. So all of these technologies are supporting us. In space, it's you're flying depending only on some sensors. So the quality of this or the quality of the output of these sensors will definitely guide us through the emptiness of the space up to the time where we reach Mars.
Now, once again, it's just a reminder that this is the UAE's first interplanetary mission. It's an unmanned mission. It will take about reach planet Mars, and of course, once it does, it will orbit the sphere for about 2 years, with a possible extension of another 2 years, depending on how the mission is going. And as you can see right behind me, we are very close to the launch time, and of course, I'll be bringing you all the updates throughout this live coverage. But for now, it's back to you guys, Ray and Yusuf, in the studio.
Yeah, thank you so much, Faraz. I think we're, less than 10 minutes away now from launch. You are, of course, watching Dubai One's live coverage of the Emirates Mars mission. At 1:58 a.m., the Hope probe is scheduled to lift off from Japan's Tenaghashima Space Centre and begin a 7-month journey to the Red Planet. Keeping us company as we wait is Fahad Al-Mahiri, Executive Director Agency. Fahad.
今回新型コロナウイルス感染症に罹患された皆様とご家族および関係者の皆様に謹んでお見舞い申し上げます。
So guys, I have shifted
社会
that
生活を
because
守り
there
維持
you
する
won't
ため
be
に
find
最
any
前線で
good
ご尽
thing
力されている皆様
to listen.
またロケット
And
打ち上
here
げ
we
作業
are
にご理解
again.
ご協力を
I
いただい
tried
ており
many
ます
things
地
and
域
that's
の
why
皆様にも心より感謝
I tried many things and that's why these disturbance you saw, but now you won't be seeing anything. Here we are at the launch and we'll be seeing the launch today, guys.
今後も打ち上げ関係者が一丸となって万全を期してまいります。打ち上げまでもう間もなくとなりました。
Here you
ここから
also
は
can see
種子島宇宙センター
the
の映像を
the
ご覧ください。
translation. We are at the Tenaghashima Space Centre and we are only 7 minutes from the launch, guys, and once this launch happens I'll be like really very happy.
打ち上げ8分前です。打ち上げに向けた秒読みが開始されました。
It's a minute to launch. We have initiated the final countdown.
種子島宇宙センター竹崎総合司令塔から H-2A ロケット42号機の打ち上げ状況をお伝えしております。
We are reporting the H-2A number 42 launch live from the Takasaki Range Control Center, the JAXA Tenaghashima Space Center.
現在各ゲートもロケット打ち上げの最終作業を行っています。また警戒区域の安全は確認されています。
All systems are now in final operation. The restricted area has been cleared.
440
It's a beautiful view, guys. You can see the launch pad here, the rocket here, and we want to see the rocket, right? That's why I shifted from that telecast and I'm here.
安全系準備完了。
Room safety system is go.
The gas.
車上系準備完了。
Room system is green.
All systems are green. Okay. The gas which you are seeing right now is because of the excess pressure in the oxygen tank, and that's why we have the bleeding valves. And because of that, the gas is leaking out. We want that leakage to happen. Otherwise, the tank will rupture because of the excess pressure. Whenever there is excess pressure, we keep on loading the liquid oxygen and till some times before the launch, because the liquid oxygen is at cryogenic temperatures, and it cools down, not cools down, it it comes to the room temperature, and that's why it evaporates then. And because of the evaporation, the pressure increases, and we have the increase in the pressure, and that's why we have the bleeding valves.
現在車上の天候は晴れ、気温摂氏 27.3 度、南南西の風、毎秒 7.1 メートルです。H-2A ロケット
We
42
are,
号機の打ち上げ
guys,
に問題はあり
5
ません。
minutes from the launch.
It's 6 minutes to launch.
Okay,
The current weather
6
here
minutes.
at the launch site is clear.
Okay.
Temperature is 27.3 degrees Celsius. Wind is 7.1 meters per sec from the south-southwest. The weather has no constraint for launch.
本日の打ち上げ予定時刻は日本時間の午前6時58分14秒です。
Today's scheduled liftoff time is 6:58:14 a.m. Japan Standard Time.
310、309、308、307、306、305、304、303、302、301、300。
打ち上げ5分前です。
It's 5 minutes to launch.
290、89、
Guys, he's just said it is 6:58 a.m. JST, and according to it, I have set the clock only, the timer which you are seeing. I don't know why he's saying 5 minutes. If the liftoff time is 6:58, then it is the countdown is
countdown
correct.
sequence has been initiated.
This is the Japanese space agencies, guys. With the Japanese space agencies launching it.
This is a live launch coverage of the h-iia number 42 launch from Taxi Range Control Center, the JAXA Tenaghashima Space Centre.
Guys, I am just
The Yoshino Block House is now commanding operations control of the launch vehicle.
34、41、42、43、34、35、36、37、38、39、40、41、42、43、44、43、44、43、42、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43、44、43
looking so beautiful, the view is looking so beautiful, and the mission will also be so beautiful. And this is the, you can say, the first interplanetary mission which I am seeing live right now, and I'm really feeling very excited. So these are the three, this is the engine, this is the solid rocket boosters engine, and these all three will ignite at once for the first stage, and at 100 seconds these solid rocket boosters will detach, and then the first stage will continue. Guys, if you just, we have 396 viewers, I want these many likes also on this stream. If you can give me, then it would be best, guys.
全システムの電源が外部から内部に切り替えられました。
The power has been switched to the internal system.
So now the it is at internal flight computer, guys. The internal power,
We
sorry.
have completed the pressurization of the liquid hydrogen system. It's its first stage.
Okay. I don't know the countdown is correct or not. Guys, only 1 minute 45 seconds, 2 minutes are left, guys. Under 2 minutes. I'm so excited. Guys, and if you want to watch each space agent, every launch in the space industry, just subscribe right now, because I'll cover each and every launch. The China will be launching to the Mars, the NASA will be launching to the Mars, and I'll be covering that.
Pressurization of the liquid oxygen and hydrogen system of the second stage are complete. We are uniting the torch to power the excess hydrogen.
It's not like that, guys. I just wanted to inform you that what I do, if you like that, then only subscribe. I am not forcing you anyone to subscribe. I don't know, will the countdown match or not?
The launch deck, the sun suppression water system has been activated.
So the countdown didn't match.
Flight mode on.
Now you'll basically see the launch and ignition. We can see the ignition, guys. Here we go. And lift off to the Mars of the JAXA Space Agency. Here we go for the big maneuver.
We have a liftoff of its vehicle number 42 from JAXA Tenaghashima Space Centre at 6:58:14 a.m. on July 20, 2020, Japan Standard Time.
Everything is looking so good, guys. Oh, and here we go. You can see the. That's what we call max Q, guys. Nothing to worry about it. That is bound to happen.
Following liftoff, the operation control of the launch vehicle has been switched from the blockhouse to the launch control center.
Now that the vehicle was passing through max Q, guys, there. Now everything is looking so good.
ロケットは現在徐々に東方向の太平洋上へ飛行しています。
The H-iia is now flying above Pacific Ocean to the east.
60ロケットは正常に飛行中であり、種子島の地上局は正常にロケットの追尾を行っています。
The H-iia flight is on course, and the Tenaghashima station is tracking the launch vehicle very well.
Everything is nominal, guys. And seriously, I have my fingers crossed right now, and I don't want this mission to fail at all.
80、81、82、83、84、85、86、87、88、89、90。
SLBA 燃焼終了。
Thanks everyone, guys, for appreciating this initiative. And I think now the rocket boosters will separate. And there we go. We have the separation of the solid rocket booster.
SLBA separation.
Clean separation we had.
16、17、18、19、120。
We had clean separation, guys. Oh, this is looking so good. I don't know when will they shift to the onboard camera. That would be so great. They could shift to that. Here you can't see the plume coming out of the rocket because it is a liquid hydrogen and oxygen rocket, so that's why it does not you can say have the residue left in the smoke which it emits, because the hydrogen and oxygen, when they combine it forms water.
第1段エンジンの燃焼は正常。制御系飛行経路も正常です。ロケットは順調に飛行を続けており、現在の高度は約
And I don't know what that thing is.
The combustion in the first stage engine, altitude control, and trajectory are all nominal. The H-iia flight is on course. Current altitude is about 95 km. Rest is approximately 1.5 km per sec.
Okay. I don't know what will they show, but yeah, everything is nominal as the guy commented. Here we go. This is what we wanted. So let me just explain what is happening here, guys. So first of all, okay, I don't want the music, so let me explain you guys. Here we have this this is the timer, 237, 238. This is we have the speed right now. This is the speed, and this is the altitude which it has achieved. Okay, maybe if this is the altitude of the apoapsis or the rocket. I suspect this is the, and payload fairing has jettisoned, guys.
The payload fairing jettisoned.
Here we have this, the event took place here, guys, and then the second event will took place which will be of the separation of the first stage, which will happen somewhere here. You can see the speed right now. It is like 2700 2800 meters per second, and it is rapidly increasing. And what about this thing? This is basically you can say the orientation of the rocket. It is so showing the orientation of the rocket, this thing. I'm so good, so excited. Everything is looking nominal.
Combustion of the first stage engine, altitude control, and trajectory are all nominal. The H-iia flight is on course. The current altitude is about 170 km. Velocity is approximately 3 km per second.
Whoa, everything is nominal, guys, and we can see the speed is increasing rapidly. Wow. If would have missed this launch window, they would have to wait till 2022 for the next launch window to occur. And now the separation of the first and the second stage will this is the next event coming up, guys. Wait for that to come up. And where do we have ETA? And first stage engine cut off.
The first stage engine cut off.
Separation of the first stage and second stage.
Separation of the first and second stages.
Engine. And here we go. We have the successful start of the second stage engine, guys.
For the first time.
Thank you so much for subscribing, guys. I really appreciate your love, and I love to interact with you guys. That's why I'm here with you. Now what will happen, guys? Now the second stage will put the Hope Mars probe into a direct trajectory to intersect Mars. Direct trajectory to Mars. Basically, it will raise the orbit to such an extent that it will intersect the Mars orbit, and where it intersects the Mars orbit, there the Mars will also come after 7 to 9 months, which is the journey period of this Mars probe. Now, as you can see, guys,
The status of the H-2A is nominal.
okay, so as you can see now, the rocket is becoming gradually parallel to the Earth. It is necessary because, as always, we say if we want to go to space, then we go just straight up. Okay, but if we want to go to the orbit and we just want to stay in space, not just go in space, but stay in space, then we go straight up, and then we go sideways, and that too very, very fast. So that's what we are seeing right now here, guys. We are basically, as you can see, the rocket is becoming parallel now to the Earth. Parallel in the sense, this thing, if this is the plane of the Earth, it is becoming parallel to this plane. This thing is becoming parallel to this plane, and it will gradually become so. And the speed,
It's 9 minutes into flight.
第2段エンジンの燃焼は正常、制御系飛行経路も正常であり、ロケットは現在安定した飛行を続けております。現在の高度は約 250km、秒速約 6.3km です。
The combustion on the second stage engine, attitude control, and trajectory are all nominal. The H-2A flight is on course. Current altitude is about 250 km. Velocity is approximately 6.3 km per second.
Yes, Steve, that weird thing that I also don't know what is that. I was also astonished by that weird white thing which appeared in the sky. Really want to talk about it. I'll talk about it once this launch happens successfully, for sure. Yes, Christopher, there will be updates in the journey for the journey, and I'll be posting it on the channel only. Yes, Jack, here we go. We have 6.3 kilometers per second.
JAXA Tenaghashima and
Ground
Uchimura
speed
stations and into the Ogasawara station.
6.8, around 7.2 to 7.5 is the orbital speed, which is the speed required to stay in the orbit, stable orbit. And it is now achieving that only, and once it achieves that, then the second stage engine will cut off. And if I am not wrong, then it will reignite the engine to put it into the Mars trajectory. I don't know, Greyard, why is there we don't have any real-time cam on the orbit. We don't usually see from the JAXA any real-time onboard camera. Here we go, guys. We have the successful deployment of the satellite into the orbit, but not into the Mars trajectory right now, but we have successfully deployed it into the orbit. And yeah, this mission is kind of successful now.
We are at the coast face now. The launch vehicle is shortly flying beyond the range of the Ogasawara station.
Exactly.
この後打ち上げから約56分後に UAE 火星探査機ホープの分離を予定しています。次のイベントまで一旦実況放送を中断いたします。
Separation of the Emirates Mars Mission Hope probe will occur in about 56 minutes into launch. Until the next major event, there will be an intermission.
竹崎総合司令塔からの実況放送は午前7時43分頃に再開を予定しております。
This live coverage will resume at 7:43 a.m. Japan Standard Time.
Okay, so now 7:43 a.m. Now we can just revert to that commentary, guys, what they are saying. We can see that.
And do something similar and gain similar experience. And why is that? Because, you know, we're a small country in the middle of the Middle East. This is all about partnerships. It's all about collaboration. You know, at the UAE Space Agency, we had set up the Arab Space Cooperation Group, and that is a group of 14 countries today and counting. You know, we're looking at a total of possibly 22 to start being part of future missions. This just took it to another level. Absolutely. So brought in 37,000 applicants.
Yes.
That, you know, these guys are going to be the, you know, creme de la creme. These are the prodigies, the Arab prodigies of space. And, you know, we've set up a few different tracks. I won't be able to disclose too much more, but there are 3 different tracks that will be opening up about this program. And in the coming weeks, we'll be filtering down those 37,000 applicants. And we'll definitely have more to announce soon on that program.
Fascinating. And we might actually pick your brains a little bit more on that during the show. We might see if we get some more information out of you. As I said, it's time to head over to the Mohammed bin Rashid Space Centre and find out from Faraz Javid, our reporter on the ground, what was the reaction over there, Faraz?
Meyer, you'll have to cue me.
Well, it doesn't sound like Faraz can actually hear us at the moment, but the highly anticipated Faraz Javid, we'll definitely get an update from him. One of the things I would like to ask you at this time, though, Fahad, when you think about all the work, all the hard work that people have put in, the dedication, the hours, you know, maybe missing family, missing friends, missing special occasions, particularly at this time when, you know, we've all been battling across the world against COVID-19 and the restrictions that that's caused. You must feel proud of the whole team, the UAE Space Agency.
Guys, I just want to say one thing that I want to interrupt and say one thing that, yeah, the mission is the first, what you can say that right now we are in the intermission for the full mission to occur, right? We the second stage has to reignite its engine to put it into the Mars trajectory, and it is right now in the coast phase, and at 7:43 what they told, the engines will reignite and we'll have the stream, we'll switch over to that again. But yeah, right now we the probe is in the orbit. It's so good, right now. Yeah. We just witnessed something that is going to Mars with our eyes, that too live. That is so good.
Again, history was made just moments ago, right here. It's again, once UAE launched its first Mars mission from Japan's Tenaghashima Space Centre. I just want to give you guys an idea over here. Just before the launch, there was pin drop silence. And at 1:50 time, when the rocket took off, there was cheers, there was joy. I actually even saw people crying. And why not? It's understandable. You know, we all witness history and we all are proud of it. It's the first interplanetary mission for the UAE, for the Arab world. And we all definitely have a reason to be proud of it. Now, another thing that I would like to highlight when it comes to outer space mission, when from around the world we hear, or the words that we hear rather, are space.
The Emirates Mars Mission is the message of hope to the Arab youth.
Guys, I wanted to shift to this thing because
less than 50 years,
this is a good
then we can do much more
information which they are providing.
The same way we used to generate knowledge in the past. We can generate
thank you so much for tuning, guys. The mission is
humanity.
not over right now. The stream is not over. Just stay here and witness the other things also. So this is the this is how the wow, this Dubai control center. I haven't seen this such a beautiful control center ever in my life. Dubai has one thing, the United Arab Emirates I should say, has one thing, that they do everything uniquely. Everything uniquely. Whatever thing they do it with full perfection and full uniqueness, and that's what we witnessed today also. So okay, I think we should...
この後は三菱重工業製作の映像をご覧ください。
Okay. No, I can't be an astronaut, but I surely can surely want to go to space someday. I would be really, what do you say, obliged to go into space someday. And okay. Okay, this is a good thing we should watch. We will have a good info about the rockets, how it made.
In the infinite beauty of the universe. Satellites. Space probes. The International Space Station. Even at this moment, various spacecraft are contributing to our daily lives, and they are able to do so only with the forceful guidance provided by rockets.
I'll explain needed anything. I am also very interesting to see this life of a rocket documentary kind of a thing. You don't know them.
The body of a rocket is made of very thin sheets.
I'll shut my mouth.
Only 17 millimeters thick. To reach outer space, the body must be light, yet sturdy. The sheets are cut into a special shape called an isogrid structure, approximately 2 millimeters thick. This makes the body lighter and stronger at the same time. Next, the sheets are combined to form a cylinder. This becomes the rocket's fuel tank. Rockets, shaped like a long and narrow pencil, are mainly composed of fuel tanks. The fuel tanks are used for two kinds of fuel, liquid hydrogen and liquid oxygen, each contained in separate tanks. In order to reach higher speeds, the rocket is designed with two engine stages, each having two separate tanks. Next is the heart of the rocket, the engine. The rocket engine combines hydrogen and oxygen together in the combustion chamber and blows high-pressure gas at a rate faster than the speed of sound. The heat from combustion rises up to 3,500 degrees Celsius, which requires the engine to be able to withstand extreme temperature.
That thing was to be paused and studied, that diagram.
Few technologies have impacted manufacturing as rapidly and broadly as 3D printing. Since its debut in the early 1980s, the global market for 3D printing vehicle. In order to achieve increased payload capacity and shorter lead times to launch, the H-3 actually is a direct energy deposition additive manufacturing system that features two world firsts: a monitoring feedback function enabling real-time control, and a local shield function to allow the use of a wider range of materials. The same technology will allow llA to work on precision parts that are not only made of unique materials, but are also much larger than what other printers are capable of handling, often required by the aerospace sector. 3D printing's rapid transition from curiosity to powerhouse technology has revolutionized manufacturing and made the future more exciting than ever before.
After assembling, the rocket is transported to the launch site in Tenaghashima, located in southern.
Partnerships are key to the fourth industrial revolution. Companies are collaborating to develop the advanced technologies and solutions society needs. These innovations generate new streams of profit and make a sustainable impact on local communities around the world. They bring dreams to life. Brescia, a town with 3,200 years of history, is located in Italy's industrial center. Here, local steelmaker Ori Martin partnered with energy technology company Turboden to install a plant that recycles the steel mill's waste heat into electricity. The process also cuts the mill's CO2 emissions and benefits the bottom line, a dream combination that many energy-intensive industries can apply.
We invested a lot in the last year, especially to reduce noise, to reduce pollution, to reduce emission, and one of the most important projects we had is a recovery project.
Turboden's organic Rankine cycle technology, which generates the electricity, is at the heart of the project.
Most of the projects that we implement are based on a strong relation between our company, the customer, and other technological providers that complement our solution. And the Ori Martin project is a clear example of this.
Thanks to this plan, we can recover the hot fumes from the electrical arc furnace and convert them into energy. We can produce electrical energy compared to the consumption of 700 families.
Half a world away is a family-owned business in the American heartland. Steer Enterprises is a long-time part supplier to global automakers. The dreams and hard work on which the founder built the business 3 generations ago live on in quality partnerships today. The company chose Mitsubishi Caterpillar Forklift America to provide a fleet of forklifts to optimize its operations.
We always say that we're building our company for generations to come, so our decision-making, whether it be purchasing a forklift, purchasing a business line, all of those are thinking 10, 20, 30 years out.
The long-term view is even more crucial in projects outside of the planet. Space has always been a dream destination for humankind, and Japan's new rocket aims to make it even more accessible. The Japan Aerospace Exploration Agency and Mitsubishi Heavy Industries are decades-long partners and are now working together on the H-3, Japan's next-generation rocket. Scheduled to debut in 2020, the H-3 will slash launch preparation lead time and price and build on Japan's world-class launch success rate.
まずこの H3 ロケットの目的が
The objective of the H-3 is to lower the barriers to space development and utilization. It's very important to make space easier to access for humankind, and we need to make sure Japan always has a means to access space. By making the H-3 rocket less expensive than its predecessors, we aim to reduce the cost of going to space. This will spark robust space development and utilization.
That's a big dream, one that cannot be achieved alone. Engineering partnerships. This is what it takes to move the world forward.
Half a day before the launch, the rocket is transported by a special vehicle to the launch pad, entering final preparations for the countdown to liftoff.
Main engine着火。 3、2、1、リフトオフ。
Approximately 2 minutes after liftoff, solid rocket boosters are jettisoned. About 7 minutes after liftoff, the first stage rocket engine will be jettisoned. From that point, the second stage engine fires. The rocket, now lighter, accelerates its speed in zero-gravity space, ready to release the satellite to the designated orbit. The speed required to place a satellite into orbit is about 8 kilometers per second. At this point, the rocket would only need 1 minute to cover the same distance as a Japanese bullet train could in 3 hours. After the satellite is separated, the rocket's mission is completed. The rocket, taking over a year and a half to manufacture, finishes its short lifetime at 30 minutes after liftoff. Rockets are continually evolving. In anticipation of an ever-evolving state of rocket development, Mitsubishi Heavy Industries is developing its next-generation rocket. With decades worth of technologies and expertise, Mitsubishi Heavy Industries will continue to contribute to humanity through the utilization of space.
When it comes to society's biggest challenges, there are no easy solutions. That's why at MHI Group, we address big issues with the power of global integrated engineering and relentlessly pursue incremental advancement. To take on the growing demand for clean energy, we're pioneering alternative energy sources and cutting emissions from existing ones. We're anticipating the needs of rapidly growing cities through advancements in transportation and sustainability. Our innovations are revolutionizing how goods get to people around the world through digital warehouses and automation technology. We're making it possible for more people to experience the benefits of space technology with our next-gen launch vehicle. And we're building connections to more destinations with a regional jet that offers more space and comfort for passengers. The biggest challenges inspire our greatest innovations. And because we're constantly working to improve, our best never stays our best for long. So there are always even better things ahead.
So now this is the thing which we all were waiting for, right? The image is captured by the onboard camera. We want to see it. So yeah, please let us see. Please let us.
では、ここでロケット搭載カメラの映像をお送りいたします。
Okay. This is the guys. This is the solid rocket booster separation. Which happened. This is the view from the onboard camera. This is the fairing separation, if I'm not wrong. Yeah, here we go. This is the fairing separation, guys. Okay. Okay, this much only. Okay, no problem. Hopefully we'll also get the okay, so hopefully we'll also get a footage from the when the satellite will be deployed into the orbit. It is right now on to the second stage only. Second stage has to raise its apoapsis to collide, to intersect with the Mars.
まもなく RCC の実況が中継される模様です。
So now we'll be back, guys.
どうぞご覧ください。
So guys, this was so informative. Seriously, I haven't seen such an informative stream till now in my life. First of all, the UAE is that animation kind of a thing that was so cool. Obviously, we all know UAE does the things which nobody does. It wants to be the one or the best. That's what's the philosophy of the Prime Minister there. They want to be the best, or they want to be the only one. And that's why we could also see that from the stream also. And then this Mitsubishi Heavy Industries Life of a Rocket documentary, this actually opened my eyes on how that the rocket is developed, basically how it is manufactured. There are so many steps which we just overlook, and we just see cylindrical structure standing on the launch pad. But to make that cylindrical structure stand on the launch pad, we have so much things going on before that. So yeah, now we are waiting for the stream to begin. The live stream, this is the live stream only. We just want okay, here we go.
宇宙センター竹崎総合司令塔から H-2A ロケット42号機の打ち上げ実況放送を再開します。
This is a live coverage of llA number 42 from the Takasaki Range Control Center at the JAXA Tenaghashima Space Centre.
UAE 火星探査機ホープを搭載した H-2A ロケット42号機は2020年7月20日午前6時58分14秒に種子島宇宙センターから打ち上げられました。
Earlier at 6:58:14 a.m. Japan Standard Time today, from Tenaghashima Space Centre, the llA number 42 was launched with encapsulating the Emirates Mars Mission hot probe.
ロケットの追尾は再開されており、現在ロケットは完成飛行を続けています。
We have restarted tracking the launch vehicle. The launch vehicle is currently in a coastal state.
まもなく第2段エンジン第2回燃焼開始を予定しております。
We are shortly going through another ignition of the second stage engine.
No, they don't. The random guys, no, they don't. Otherwise, they wouldn't have sent the. Obviously, nobody believes in flat Earth kind of thing, because what should I say? I am not a flat earther at all. And I just remember that thing here which happened during the launch. We saw that white flashy thing which came from nowhere, and we don't know what was that. Hopefully replaying the stream which I could do after the stream ends can reveal something. Was it a rocket part, or was it you can say a SRB part which was stuck on the rocket? I don't know. We will see, and we'll try to analyze that when we'll have the stream. So we are just waiting for the stream to resume. Right now the vehicle is in continues to fly smoothly because it is in a coastal state. When it will reach a phase or at a location where it can start its injection burn, then the second stage engine will reignite and we'll have the burn. Wait, let me just shift it to again to that only. There we go.
And you discover a solution to another problem, which you sell into another area or create something completely new. And so it's not just something that's one product that you're making. These things lead to innovations, which, I mean, we've seen innovations over the last sort of 50, 60 years, which have just changed the way we all live our lives and our world. And you just never know what's going to happen with that sort of spark of inspiration.
Correct. And that's the thing. When you have those labs, that's where it comes from, right?
Yeah.
It's not just about copying somebody else or learning from somebody else and then just replicating that. This is now about figuring out the why I'm going into this and figuring out how to really get into that. And, mistakes that maybe become, a spin-off at the end of the day that become the success than the original project at the end of the day.
Let's stick with the theme of innovation and futures and chat to our next guest now. We're going live to London to chat to Dr. Ina Steenmans, Assistant Professor in Futures Analysis and Policy at the University College London. Ina, can you hear me?
I can hear you fabulously.
It's wonderful to have you on the show. First of all, your reaction to the launch. Did you get the chance to...
I did. It was a very emotional moment, I'm sure, for the team. It's incredible what they've achieved.
Yeah, absolutely. And tell us how you came to be involved in the Hope probe, in the Emirates Mars mission, because you've got quite a involvement in this program, a research involvement.
That's right. So about a year ago, a group of us at College London met with the mission team, and we were so interested in hearing about and has used a science mission, a space mission, intentionally to, in the long term, change the future of the UAE, change the foundations for its economy, and specifically to bring in a greater role for science and innovation, as we just actually heard, a greater role for R&D and being able to do new things. And as we were talking, we couldn't help ourselves but ask some really tough questions. Because wondering, you know, it's a great idea, but in practice, can a space mission really be this key to unlock a very different future? And even though Hope is very young, it's only been a few years, what is it that other space missions and what evidence is there of impact on the ground? And then what happened is that the mission team basically said, well, great, we have the same questions, so please can you work with us, or rather, can you independently do an external study of what the value of the Emirates mission to Mars is? And that's what we did, and a few weeks ago we published our findings.
Doctor, you've met some on the ground in the Emirates Mars mission, young people, rather, in training as well, haven't you?
That's right. Actually, we heard about them just before. So the reason why we met a range of people, actually, so both internal to the team, external to the team, we met a lot of the young people who had been engaged either through the school outreach program, so tens of thousands of children have been brought in to get them excited about space, get them excited about science. But we specifically made sure that we met with some of the sponsored research students that we heard about a few minutes ago, because these are young minds who've basically been picked and selected and match-made with international space leaders in climate science. And then they spent their summer doing really advanced research projects. They came back with this new knowledge, new skills. And what was really striking about meeting these young researchers is just how thoughtful they were and really how passionate they are in terms of seeing themselves taking on a different kind of role in shaping a future of science within the UAE. It was a really, really great part of the research process.
Yeah, I mean, it's always great to meet young people working on any project, especially when they're excited about it. But what did you discover, Doctor? You were tasked with finding out the benefits of the Mars Hope probe. What did you find out? What are we going to see those benefits as over the next few years, do you think?
Well, actually, we heard that normally when we look at the value and the benefits of space missions, we tend to look at things like new jobs, new revenue, or areas of additionality. So where we already have a sector that we're great at, like logistics, and then something new like structure, new skill sets to enhance that. Or we get really excited sometimes when we think about spin out or spin logistics, then creates value for the UAE and its health care and medicine sector. But with the Emirates mission, if we only look there, then you'll actually be missing a huge part of the picture of benefits and value. And that's the societal benefits and the transformative value that's being created. Because this mission is a really intentional piece of the puzzle in terms of radically the national future, economic future of the UAE. And that transformative value, that's actually surprisingly not something that people talk about a lot with space missions. And with the UAE, it's been there from day one. And that's been amazing to collect evidence on and to basically explore just the kind of change that's already been causing.
Beanmans, thank you very much for joining us on this video call, and all the best as well.
Thank you very much, Doctor. And there you hear it, isn't it? That's sort of the proof is in the pudding. You know, it's all very well us sort of sitting around and talking about you know, the space program and inspiring young people. We've actually done a scientific research into the benefits of the Hope probe. And I was actually chatting to Dr. Steemans a little bit earlier on before today's program, and she was saying that what they've discovered is actually something that could change the way that other countries approach their own missions, whether it's to Mars, the Moon, wherever it might be, because of the model and what they've learned from this actual mission. And in that sense, it could be completely revolutionary.
Yeah, I mean, I fully agree with that. You know, I've seen a few launches, but nothing as inspirational as the way the UAE has put it together, to be honest. You know, it is really there. That is because that was part of the mission. You know.
Can you allow me just for 1 second? We have a guest, and I think it's very tough to keep on hold with us, and that is Dr. Michael Mayer. He is the program scientist for the 2001 Mars Odyssey mission and the senior scientist for astrobiology at NASA. He joins us now from his home in Washington, D.C. Dr. Michael, can you hear us loud and clear?
I can hear you loud and clear.
Ooh, and we can hear you loud and clear. It is crystal. Doctor, as a program scientist, you know that the importance of the mission concept. How important is the HOPE probe's mission to get the first complete picture of Mars's seasonal atmospheric cycles? Could you tell us?
You know, HOPE is really critical in our quest to understand the climate at Mars. So far that we've been doing with Mars that do polar orbits, we see places on Mars at a particular time of day, or we only see them in one particular place. So now HOPE is able to actually look at Mars synoptically. You can actually get a much better idea of dynamics, see what's going on, not just in one place, but see across the whole globe. So this is just fantastic. The mission is going to really help us fill in a lot of dynamics of the Mars climate.
So we're hoping to get a lot of information from the HOPE probe when it starts to orbit Mars. But how much interest has the scientific community as a whole, but obviously specifically from Mars researchers?
So the scientific community is really interested in, on a broad sense, in looking at Mars and its climate because it has climate. It has an atmosphere like Earth. Earth has an atmosphere, and we understand the climate reasonably well on Earth, but it's all based on models where we can tweak the little parameters. Well, Mars is very different. And although it has an atmosphere and climate, because it's so different, our models may not work. There are myths about Mars. We can't actually figure out how Mars was warm enough early on to have water on the surface. So there are challenges to understanding Mars climate, even though we think we understand Mars climate, and certainly based on Earth's climate. So what that does is what we learn from Mars with more instruments and looking at synoptically is that feeds back into our understanding of the models that we use for doing climate and actually very specifically help understand Earth's climate.
Let's see. Dr. Michael, the UAE has managed to design and launch HOPE within 6 years. How do you read that when you hear that a project that could be finished in 10 years was done in 6 years? How does that actions in your profession and expertise?
I thought it was pretty impressive when I first heard about the HOPE mission. What they just started, in 2014 is when they announced the mission, and here it is, we're in 2020. It's launched off the planet, it's taken the first step to Mars. That's a very short time for any mission development, much less the first time that UAE has done an interplanetary mission.
And we just actually heard the first signal, received the first signal from the HOPE probe just a few minutes ago. So that was another key moment. Of course, this first mission, as you said, from the Arab world, what's the impact of that for the space community as a whole?
You know, I think it's one of those things where space exploration very much is a human endeavor. And adding another spacefaring nation to the club, I think, is fantastic, because it really makes that exploration even more of a human endeavor instead of just the province of a few nations. I think it's great on an international level. It keeps all of us talking the world in a quest for information as we explore the universe before us.
Dr. Michael, in the last question, we're really interested in your answer and your thoughts. What were your thoughts when what you heard down is going to be an era, a new country is joining planetary missions? How did you think about that?
It is very emotional for another nation to be joining in space exploration, and to hear the countdown in another language, to know that it's being launched from Japan. I think it's just inspirational on a very human level that others are joining space exploration. And I find that very heartening to know that mission being so collaborative, be able to do this and get on the eventually collecting data that's basically everybody would like to know.
Dr. Meyer, thank you so much for joining us. It looks like an absolutely there in Washington, D.C., and it's the dawn of a beautiful morning here in the UAE for us as well, and the UAE space program. So thank you so much for joining us this morning.
Yes, thank you indeed.
Dr. Congratulations, UAE, and go Hope.
Thank you,
Thank you very much. Thank you for that.
Absolutely.
Such kind words.
Yeah.
That's actually really wonderful to hear that. It is really wonderful. I mean, such an accomplishment. It's wonderful when you can feel happy towards an accomplishment that you've really worked so hard for, and to hear others who are part of that race rejoice with you with that accomplishment. And again, of course, we confirmed that. We just heard that we've actually heard from the first signal after the probe has launched from Tenaghashima Island in Japan. That is another moment. We could say the time has resumed, Martian, from 1:58.
Another very, very special key moment, and a sign that things are going the way that they should do, that it needs to head in. And I think what you've just said there, Yusuf, is absolutely true. Everybody around the world who's interested in this, whether it's on a sort of a peripheral level or a scientific level, whether they make their living out of the study of Mars and space exploration in general, is you know, very, very impressed so far with what they've seen, and nothing but positivity mission in general.
No, I think that really, you know, goes, you know, towards the vision of our leadership here in the country. I mean, you know, they have taught us to inspire. They have taught the management, the ministers, you know, how to drive this country forward through, you know, their own model and their own behavior. And, you know, that goes to show, and this is why the huge respect that you see from other countries and other nations today. You know, like I said, we've had so many, you know, good luck messages from all different space agency, you know, from Brazil, from U.S., from Canada today, from the U.K., you know, from all the way in Japan as well, from Australia, you know, Washington itself. It's been phenomenal, you know. I mean, just for me being part of this for the last 5 months, just to see how a project like this is bringing the world together, and now to, you know, hear the congratulation messages, and I'm sure there'll be many more to come, you know. Yeah. It is, sorry, just, you know, because I don't know what's happening right now. I'm here in the studio with you guys. You guys are hearing that there is some communication.
We've got the earpiece,
yeah,
so we're lucky. So we're just passing. You know, we're just passing.
Thank you, but that just really brings a lot of joy to my heart, because I know, you know, have we sent out a dead satellite, or, you know, now the fact that it's communicating means that it is following protocol, it is following what it has been programmed to do. Now that means the operations room is going to be busy for the next month, 24 hours a day.
Yep, that's
you
right.
know, getting the information, taking a look at what's happening, correcting any course, taking a look at the systems, making sure everything is nominal. You know, and that thing is going to accelerate then, you know, with the hydrazine, you know, and RCS thrusters and everything to correct anything that it needs to through the star tracker, the sun tracker on its way. And then the next big thing is the Mars orbit insertion. That is the next big challenge.
You want to know more about the signal, don't you?
Yes. I'll tell you some more in a moment, hopefully. You are watching Dubai One's live coverage of the launch of the UAE Hope probe, which has just sent its first signal back to Earth. And we're going live to Tucson, Arizona now to speak to Nathaniel Putzig, senior scientist at the Planetary Science Institute. Can you hear me? Nathaniel, can you hear me? Well, we seem to be having a little bit of trouble reaching Nathaniel in Arizona right now. I was going to say, Than, we got the signal. What an exciting moment this is. But he didn't get my signal.
Too bad he's going to stay in suspense for a while longer.
Exactly. In just a moment's time. Oh, we might now have him.
Yes.
Than, can you hear me? Tucson, Arizona. Can you hear me? Okay, I think we can hear you, Nathaniel, but unfortunately, sorry, we can't hear you, but you can hear us. So we will try and get in touch with you in a few moments' time. It's just how it happens, isn't it? Signals don't always come across as clearly as we'd like them to.
I would love to say that we are now even.
Absolutely.
So Fahad, this, as of course some of the speakers at the Mohammed bin Rashid Space Centre expressed, it is a roller coaster of emotion. We've been through the whole 9 yards. We've been through the preparation phase, we've been through the delays, and now we're here, and everything we've studied and soaked like a sponge in terms of information has been forgotten. How many signals are we waiting for you?
It's just the one.
It's
the deal with that. So that allows us to basically ping back and forth, and the communication is there. So, you know, what for is, you know, you have the deep space network. So there is the 3 different sites across the world. I believe maybe there's actually 2 in the U.S., 1 in Madrid and 1 in Canberra in Australia. And so these are the ground stations that are actually there that can connect with, you know, distant objects that we send out to go out, not just in LEO and you know, Earth orbit, but further out, and, you know, out into Mars and even past that. So,
yes,
you know, we had to wait until, you know, that signal gets there, and it, to me, honestly, is just a huge... I mean, I just sent Imran Sharaf, the project director, a congratulations message, because that is really when you know that it was a success, you know.
Right here, we're in the studio?
Yes, while the last interview was going on, so...
We said no mobile phones. We made that very clear. No, you're allowed. It was an important message, actually.
We're the ones who are not allowed to have that.
Yeah, exactly.
I needed to have it just in case, God forbid, anything were to happen as well.
Yeah,
but alhamdulillah, you know, a success till now, you know, so hopefully it's all the way to Mars from now.
Absolutely. Well, in a moment, back to the Mohammed bin Rashid Space Centre, we're going to catch up with Faraz, see what the reaction's been over there. You never know, we might take another look, well, if we're lucky. But we are probably coming very close to the end of our live broadcast here on Dubai One. The rocket's up. It's gone up. We've received the signal, and we've heard from people all over the world. It's been a very special day, very special morning. What do you think the reaction of... Because not everybody would have been able to stay up and wait and hear. What do you think the reaction will be in the morning?
I also think, before he answers, I think we have Nathaniel Putzig with us. Can he...
Than, can you hear us?
Hello.
Hello. It's great to hear from you. Nathaniel, thank you so much for joining us all the way from the United States. Let me ask you this question. You've been involved in a number of Mars missions, including Mars Express and the Mars Global Surveyor. Why is it important, in your view, that we need to research the red planet in so much depth and detail?
Well, I think that the whole quest to send people to Mars is a big driver, actually. I know the United Arab Emirates has a long-term plan to send colonists to Mars, so we need to understand everything we can about it. And the Emirates Mars Mission is going to solve an important piece of the, particularly about the climate as it varies from different times of day.
See, Mr. Nathan, the geology here and climate history of Mars for the last 20 years. Probe discover that we don't already know.
Well, one of the things that we're trying to get a better understanding of is the changes in the atmosphere interact with the surface. In particular, it's like water ice and CO2 ice that freezes out on the surface. And we don't fully understand how that interaction works on an annual basis. So the HOPE probe is going to help those atmospheric elements that interact with the surface, and then we can better understand the whole history of the ices and the layers of ices in the polar caps.
Absolutely. Nathaniel, thank you so much for joining us. So, unfortunately, we're going to have to cut it a little bit short because we're having a little bit of trouble hearing you, but we are going to go over to the Mohammed bin Rashid Space Centre right now because Faraz Javid, intrepid reporter, he's going to give us a little bit of update from the Mohammed bin Rashid Space Centre, where there must have been so much action and excitement over the last hour and a half, 2 hours that we've been on air, because other than being right there at the launch site in Japan, that's very much the place to be.
Pretty much, and to be very honest, Ray, I mean, this roller coaster is really high, and it takes a time until it goes down and you can give your rejoiceful screams. First it was the launch, and then you wait for that signals. You wait for the signal, basically. Yeah. So now, the man of the hour for us is Faraz, coming back to us with all of this information. Let's see, Faraz, live with us from the Mohammed bin Rashid Space Centre. Now that we have gotten a signal, can you tell us what is the mood there? What do we have? What can you give us and relate to us, Faraz? I think...
He was looking at his tie, and Faraz, if it helps you, reassures you in any way, shape or form, your tie looks great, your whole outfit looks great, and so is your report. We'll come back to you as soon as we possibly can. It's not always easy, this communication business, is it? Should we give it another try?
I'm beginning to think it is personal.
I'm sure. Try him again. Try him again. It won't.
All right. Right, going to Faraz, who is live at the Mohammed bin Rashid Space Centre.
There you go, guys. Once again, the UAE's first interplanetary mission is on. The successful launch Space Center in Japan to the separation, and of course the connection that was just established a moment ago between the probe and Mohammed bin Rashid Space Center. So it's official, the UAE HOPE probe is on its way to Mars, and of course in 7 months' time, the humanity will reap the benefits for many, many years to come. And on a personal level, we'll always cherish this moment to be part of this historical moment. And of course, I'm Instagramming a lot of pictures that I've taken. So for now, myself, Faraz Javid, and my team, Mahir Abu Drawi and Mohammed llA, it's bye for now. But Ray and Yusuf, I'll catch you guys at the breakfast table. Till then, take care. And, of course, good morning.
He's not lying, you know. He will be Instagramming it. He'll be Instagramming. He's probably been Instagramming already.
And he's not wrong. We will be catching up. But I think we have a couple of minutes here. Yeah. So, of course, we have to, give you our utmost appreciation for being with us here in the studio. And we got to know if you have any message for the people out there on this historic day for us.
Well, I'd personally like to just send out a message to the Mars Mission team, to the EMM team. You know, personally, I've seen what they've been through, and I'm so proud of the team. You know, I'm sure you know, the leadership is proud. I'm sure the whole world and the whole country is proud of what they've achieved here. You know, we even have one of our engineers who has held back getting married, and you know, it was all about we'll get married after the launch. So you know, that is something.
You've got to have your priorities straight, haven't you? I think in this case that was the right thing to do.
Thank you very much for this, Fahad, and congratulations to you, congratulations to the UAE and to the Arabic nation, and congratulations to you as well, Ray.
Oh, thank you very much. Yeah, I was heavily involved, I'm sure.
Absolutely. This is a wrap-up. Ladies and gentlemen, thank you very much for watching us on this exclusive coverage. Remember this date, remember this moment, and we will see you on next coverages and episodes, and keep waiting for those 7 beautiful months.
Yeah.
So guys, you just saw the launch of the Mars mission, the Hope Mars mission on board the H-2A rocket, and we just saw it being successful. So guys, were you excited? And now, since the launch is successful, now the Hope probe is heading towards the Mars. That is so much exciting, because right now this thing which the Hope mission will accomplish, no space agency has accomplished till now. So yeah, that's the thing which we are seeing right now, guys. Okay, so one more thing, NASA and China will also be launching their own Mars mission, which will be happening in late July and early August. So I'll be covering that also with every information from the rocket, the payload and all. So just stay tuned, and I'll be there with you. Also guys, I want to yeah, tell you that, okay, let me just yeah, first of all mute this thing. Okay, right. So yeah, so I was saying, what was I saying? I forgot. Yeah, the Mars, the home and transfer. Yeah, I was telling you about the home and transfer. So if you know home and transfer window and the home and transfer, then it is good. And if you don't, then I'll make you see if I can. Guys, let me see. Here we go, guys. See, this is the home and transfer, guys. You can see this is the transferring thing, which the transfer trajectory for the InSight lander of the NASA, which happened. And here, as you can see, this how it happens when if the probe from here achieves 11 kilometer per second kind of speed, then it escapes from Earth's gravity pull. And then what happens in an home and transfer is, it is first of all the most efficient burn, okay, which happens. And also the apoapsis of this trajectory meets this Mars orbit. And when it meets the Mars orbit, the Mars is also there to capture that. And to capture it, we perform a retrograde maneuver when we are close to Mars. When we are in the sphere of influence of Mars, basically we perform retrograde maneuver. What is a retrograde maneuver? Retrograde maneuver is basically facing the engines in the opposite direction so as to slow us down, burning in the opposite direction, okay. So if we burn in the opposite direction, our speed will decrease, not increase. So that's how we brake in space. If we want to accelerate, then okay, start up the engines and go, that's cool. But if we want to decrease our speed and perform the braking, then we just orient the spacecraft in the opposite direction and then start the engines, and Boom, we are breaking now. So that's the thing which solar panels not deployed. You are you saying that we didn't see the deployment of the solar panels? Yeah, we didn't see the deployment, but I think officially it was deployed. Let me check. If it wasn't, then no, please don't tell me this. Let me check it once. Wait a sec, wait a sec. Christina, do you have, how do you know? I didn't know. First, they just tweeted that only that the first sign of the hope is the first signal from the hope probe has been transmitted. Ha, okay, yeah, the solar panels of the hope probe have been deployed. Yeah. Done. Okay, it's done. So that's cool. So yeah, I was telling you about this thing which will happen. So for the human transfer to occur, we have a special window which occurs in July and August of every 2 years. So when the Mars and the Earth, if we plot the angle, they between the sun, the Mars, like the Mars and the Earth, that will be around 44 degree. That's where we have the launch window. Okay, so guys, so today if let me just conclude the stream now. uh, it was such a spectacular launch we just witnessed, and we also we witnessed uh, such a beautiful stream from the UAE Dubai One channel also. Yeah, that was a Dubai One stream. That's why we didn't have a technical thingy there, but then also uh, everything other than that the Mars and the Earth is at the closest point, everything was correct. And then saw the spectacular launch, and one more thing which we have to discuss is that flashy thing. If I can just revert back, let me just revert back and see what was that flashy thing. I would love to see that thing again. Let me see if I can get here we go. So during the launch, we'll see if that flashy thing was there or not. Or was it my mouse? I don't think so, it was my mouse. We saw something whitish uh thing. Yeah, here we go. I saw that one here. I had a look after some time. Sorry, that must be my. After some time it occurred, right? So if we see, uh, let's just see the stream only and try to get what happened. What was that? Was it a part of a rocket or something else which came into the site? Uh, uh, there's the thing. What I think is that the here we go. Here we go. Here, this is what I think. That flashy white thing was the SRB only. Basically, we are viewing this rocket at a fixed angle, right? And it is going away from us, and maybe the camera's field of view captured the SRB's descent also. So that could be that, because at such we can't see the speed of the rocket. Obviously we can't see the speed of the rocket, means visually, but seeing the descent of that flashy part was that it can be concluded that it was some part of the rocket. From the visual speculation, I don't know, maybe it is or maybe it is not, but since the launch is successful, then we should not care about it. I don't think so it was a part of the active rocket. It was it was SRBs in my point of view, but I don't know, maybe I'm wrong. We don't know. So yeah, then obviously the mission went well again. Everything was good, and then finally, guys, we had a great deployment of the satellite. Also, I would like to mention one thing about the Mitsubishi Heavy Industry, that yeah, we were able to witness a spectacular manufacturing of the rocket, and I just truly grabbed most of the information, and from that it was very informative, biography kind of a thing, the life of rocket. Yeah, it was so good. And yeah, that's it for today, guys. Thank you so much for tuning in, and I'll be there. Okay, so SpaceX is launching one of its satellite, NSS-2, if I'm not wrong, the South Korean NSS-1 or NSS-2, the South Korean military satellites, tomorrow. So I'll be there with you tomorrow, guys, streaming that launch also. So if you want to see that, just subscribe, and I'll be hosting that too, with everything, explaining everything. Thank you so much for tuning in, guys. Good night, good morning, good afternoon, good evening, from wherever you are watching. Just stay safe, stay healthy, guys, and thank you so much for tuning. I just love interacting with you guys. Thank you so much for tuning in and watching this stream, and listening to my commentary. I know I don't speak well. I speak rubbish and all, but yeah, whatever best I can do, I am doing. Not, and I'm improving also. So if you want to support me, then you can subscribe. Okay. So yeah. So just stay safe, stay healthy.